what is MATLAB actually here? You see here maths, graphical programming. So means math means that any kind of mathematical computation, like scientific calculations or just a simple calculations, complex computation, mathematical computation, you can do in MATLAB. Further, if you have to visualize your data or your equations, there are different ways of visualization in MATLAB, like in frequency domain or time domain, or in other for domain. If you want to visualize your data, you can do it. Just 1 minute, no? Okay, just I have to go to it. Fine. So, programming, you can do a programming also in MATLAB, any kind of programming like which you do in C++, you can develop in MATLAB as well. Thing is that high level, like, just wait a minute, someone is not muted, maybe. Okay. Fine. Okay. So you can do a programming also. MATLAB is a high level interpreted language. So as I said, it is high level. It means that it is very user friendly functions which are available in MATLAB. So like mathematical equations which you write in your notebook, as it is you have to write in MATLAB. So you don't require to remember all functions which are available in MATLAB. So it is very easy. Two things you require to know in MATLAB, that what you can do with MATLAB, and how to get help in MATLAB. How to get help? Why I'm saying, because for each and every functions in MATLAB we have documentation. Okay. Next, uh, let me start from here about live script. I will like to explain. Like if you are using MATLAB previous version before MATLAB 2017. Okay, in that case we had just a script file, and in a script file, when I had any figure, let's say I wrote some programs for figures. When we are executing that script file, my figures were coming in different figure window and numeric values were displaying on command window. But now there is a live script in MATLAB where you can visualize your figures also, as well as numeric data in a same live script. And using live script to teach students, it became very simple and easy to do these things using live script. We will see more capabilities of live script later. So we are going to start from here. So, use of MATLAB with over 1,000 common hardware devices for more than 130 hardware vendors means more than one thousands of hardwares are supported with MATLAB with 130 hardware vendors. You can interface. Like if I am talking about low cost hardwares, you can interface Arduino, Raspberry Pi, or your Android mobile. Even if you want to generate a .apk file, Android apps, that also you can do using Simulink in MATLAB. You can generate it. Just use the blocks in a single click. You can deploy that app in your MATLAB. Sorry, in Android mobile. Okay. Second thing, that your MATLAB functions are ready for commercial and production. So integrate MATLAB with your production analytics applications. Also, you can integrate with production analytic applications as well. Means you can create applications, and if you want to do some kind of production analytics, there also you can use it. Integrate with the code written in other languages, like as we discussed that you can generate library and interface with these languages. Plus you can not only generate the libraries. If you want to compile C in MATLAB, or if you want to interface Java in MATLAB or .NET, that also you can do, as well as you can run Python libraries also in MATLAB, or if you want to run in MATLAB in Python, that also it is feasible to do in MATLAB. Run algorithm faster and with big data means, let's say if you have a big data are basically two types: a data which cannot fit in your memory, or data which can fit in your memory, but for execution it is taking very long time. Okay, so parallel computing and is there in MATLAB. You can use parallel computing, and using parallel computing, you can distribute your data on GPU and CPUs. Whatever cores are available in your GPU and CPUs, you can distribute it. Not only data, you can iterate your independent iterations on GPU and CPUs as well. So just you require a parallel computing toolbox. And further, there is a MATLAB parallel server as well. Let's say if you have a cluster and if you want to run your algorithm on cluster, then you can use parallel MATLAB parallel server license for that. Plug into Simulink and Stateflow for simulation and model-based design. So I will like to discuss model-based design as well. Stateflow is a state. There you can design controllers for your plants or any kind of things which you are designing. If you have to design a controller, you can use Stateflow. There you can use a state chart. There. You can use flow chart. You can use combinator kind of models, means based on the graphical user interface way you can design your controllers. Model based design means if you have to design any hardware in real time or any application say in real time, directly you can't launch that application in real time because it takes long time to design it. Maybe you are not getting a desired output when you directly when you start designing a real time. So in model design, you can use from configuration means what requirements are there for that, and then model in the loop, software in the loop, hardware in the loop, processor in the loop. All this process you can do in Simulink. Simulink is used for model based design, means design your plants controllers virtually there, then test it, verify it. We have Simulink test, Simulink check, Simulink coverage, embedded coder, C coder, STL coder for verification, like software in the loop or hardware in the loop. Hello, I am audible for everyone. My voice is coming. Okay,
Yes,
actually,
sir.
someone muted me by mistake. So maybe there was no voice for some time. Okay, okay, fine. Thank you. So please, I request you of all that don't mute myself. I mean, to me, after generating an algorithm in MATLAB code, you can deploy in C and CUDA. You can generate C or CUDA code. CUDA code is used to deploy in GPUs. And you can generate a SDL code, means hardware description language. You can generate it and you can deploy in FPGA boards as well of your algorithm. Okay, you can trust the results you get in the MATLAB because recently engineers and scientists send a spacecraft to Pluto. They use MATLAB to transplant organs in donors in patient. They take it. They trust very highly on MATLAB because of its accuracy. As it is written, a team of MathWorks engineers continuously verifies quality by running millions of tests on the MATLAB codes base every day. So for each and every function, million time they test the functions that for the high accuracy and for the reliability and readability everything. These are some companies, few logos I took it here. If you want to check that what more companies are using, you can visit mathworks.com. So these are some companies which they use MATLAB for aerospace and defense. And let me tell you, ISRO and DRDO as well, they use in India MATLAB for in some applications. Okay. And in consumer electronics also, these are some companies which they use MATLAB for their purpose. Industrial and automation machinery, Volvo, even Tata and Mahindra also use. I had discussion Mahindra very widely. They use for driving system. So there are toolboxes for driving for ADAS. We will discuss about that toolboxes also. These are some universities which they use MATLAB. If I'm talking about India, all IITs and IITs, they use MATLAB. Campus-wide license, actually, they use it. That is a limited license. They can use anywhere in the world if they want to use it. Okay, just wait a minute. Okay, they use, if I'm talking about the top universities of the world, top 200 universities, they use MATLAB for that. Okay. Okay, next, here you see generic applications like any kind of applications if, in Simulink. Simulink, you want to design it, you can design it. Simulink allows you to model and simulate a wide range of dynamic system. So as it is written that the dynamic system, Simulink is used for the dynamic simulation, means the blocks which we use here there in Simulink. And MATLAB scripting is a static kind of things. These examples model a variety of general applications. I mean, these applications which you see like simulation of bouncing ball, hydraulic cylinder. Uh, for this, you require just mathematical equations to design this kind of applications in just simulating. About machine and deep learning means the applications which you can design using MATLAB. So, like speech recognition, if you have to recognize the speech of someone, there you can use machine and deep learning in MATLAB. Object recognition, like if you have to track something or recognize some objects or humans, you can use here also machine and deep learning in MATLAB. Engine health monitoring. Let's say that if you have to find out the remaining useful life of your engine, or if you have to find out the faulty and non-faulty data of your engine or system, that also possible using machine and deep learning. And from MATLAB 2019, there is a predictive maintenance toolbox. I will show you one example on that as well, how to detect the faulty and non-faulty data uh, using machine learning. Weather forecasting, this is also application of machine and deep learning to forecast the weather. And energy load forecasting, let's say if you have to find out what will be forecasted power of your institute next day, this kind of applications you can design in MATLAB. Not only this, if someone is from economic management, let's say from banking, or someone is working in stock market, so you can create a stock market forecasting and predictive model in MATLAB. There is a trading toolbox special that from where you can log data from MathWorks. Sorry, not from MathWorks, from the vendors which they provide this stock market data in MATLAB, and you can create a predictive model using machine and deep learning. IoT analytics, MATLAB provide you a complete IoT as well. Like for complete IoT, we require sensors. Sensors already you can interface with MATLAB, and it requires a data aggregator, clouds, internet cloud. So there is a product of MathWork that is ThingSpeak. ThingSpeak is free for students. They can access ThingSpeak to log data from sensor. Okay, for analytics, you can use MATLAB. This is the third node which you can use it. If you don't have numeric data, you can use text data as well to create a machine and deep learning model. So there is a text analytics toolbox in MATLAB, a special toolbox to do analysis on text data. Not only this, using text analytics data, you can log Facebook data, Twitter data through API, and you can find out the emotions of users who are using that, they are positive emotions or negative emotions. And this kind of applications you can design it using text analytics toolbox. Airline flight delays applications, there you can use in for flight delays predictive model, because in some cities, in some cities of the world, in the world, that if there is a delay of more than 1 second, then two flight can be crashed. So to find out the accuracy, that what will be a delay time of a flight, it is very necessary to predict that. And from 2016, deep learning accuracy is higher than human as well. We can be wrong, but about machine learning, will have a less chance to be wrong for that. Okay. So these are applications which we discuss, that is a part of a machine and deep learning. And machine and deep learning in MATLAB. We are going to show one applications as well on that on machine and deep learning. So machine and deep learning are divided in two parts, that is supervised learning and unsupervised learning. So you can use both in MATLAB: classification, regression, and clustering also. So these are the algorithms. We will discuss it later about in detail. Later we will discuss about machine learning. Just I am showing you applications. So this is a deep learning also supported. Like here, this image you see, this is a part of a machine learning. Let's say if you have to extract the features from the car. No, let's say that I have to train this car in machine learning. Then I have to extract some features from the car. Then we have to provide this machine learning algorithm. Same thing if you have to do in deep learning, you have to train the car. Then here we don't have to extract this feature. You can see that feature step is removed from here, right? So this deep learning, like CNN, convolutional neural network, will do this things for you. It will extract the features of car. So there can be a different kind of cars. There can be a Maruti, there can be a Suzuki, there can be Wagoner. Then what can be a feature from car? It can be a car's bonnet size, car size, dimension, and all these things can be a feature. So here you can say in deep learning, a computer model learns to perform classification tasks directly from image, text, or so. So deep learning is also machine learning, but there is a difference that it extracts the feature directly, and there are lots of layers, hidden layers. Okay, so we'll discuss about layers also. Okay, fine. Next, why deep learning in using MATLAB? This is very important. That there are lots of softwares like Python is there, low level language, or oh, sorry, medium level language. If I'm talking or high level, then there is a C plus plus also. There is R software also you can use for machine learning. But why MATLAB? This is very important. So if you provide the same environment for TensorFlow and MATLAB, it is 7 times faster than TensorFlow and 4.5 faster than Cafe 2. Not only this, there are more advantages using deep learning MATLAB. Like GoogleNet, VGG16, VGG19, AlexNet, ResetNet. These are the open source models. Some are designed in MATLAB already, some are open source. So that models you can import in MATLAB, and you can use that model for your data. So what is the benefit of using a already pre-trained model? You don't have to optimize your parameters again. First, second, same thing which is already trained. If you are going to train again, it will take a lot time to optimize the parameters and to get the final model for that. So we have here ONNX, Open Neural Network Transfer System. There is a add-on. You can use that to transfer open source deep learning models as well. And plus, MATLAB is GPU supported. You can distribute your batches, number of batches and epochs on GPU also, NVIDIA GPU. Okay, use functions and tools to visualize intermediate results. So there is a debug option also in MATLAB. Very easy it is to do in live script. We will discuss how to use live script later. And the most important thing is ground truth labeling. Let's say you just collected the data, but you don't have labels, you don't have class for your data. So we have a ground truth labeler apps for that. Ground truth labeler apps, let me show you what I am talking about. If I go in app, if I go first of all in signal processing. So there is, you can see, if you are using audio data for machine or deep learning, there is a audio labeler app. You can label your data using this app, and you can automate all this process on all samples. Same there is we have for image processing also here. Like you can see image labeler app to label that image. Let's say if you are doing semantic segmentation, like based on the pixels, that this is a pedestrian, this is the road, and this is the car, this is a building, this is a green area. So you can use this image labeler, or if you have video, then you can use video labeler also to label your images. So these labelers are very useful for design automated driving system as well. Working with models, you can work with Cafe and TensorFlow and Keras models. This structure which you see here. This is a neural network. So this is a shallow neural network actually. Shallow, there is only one hidden layer. Okay, that is a shallow neural network. That is not a deep learning. In deep learning, if I am using neural network, there are lots of hidden layers. That it can be 8, 10, 20, 30, 100, 200 as well. So why I told that this is a not a deep learning neural network, because here you can see all neurons are connected to the next neurons. Means for this neuron is connected to all next neurons. Then this is connected next to all neurons. But in deep learning, it will not look like this. Maybe these neurons are connected with this three only, and these are connected with this two only, like this. Okay. So these are transfer learning, means as I told that already pre-trained models are which are available, you can use as a transfer learning, means for your data. So these are this some already pre-trained models of Google Net, ResetNet, SqueezeNet. If you are using all this, you can import in MATLAB. For Keras TensorFlow, we have a Keras TensorFlow importer. For Cafe model, if you have a we have a Cafe model importer and open neural network model. You can use the ONNX model converter. What it will do when you use this ONNX, it will convert your open source deep learning models in MATLAB algorithm, MATLAB way. Okay. So we have here app also in MATLAB to design the layer. So I am going to run this video for some time. So like this, you can drag the layer. You can design your deep learning layer. So this attractive app is you cannot find in other software. So you can see it how it did it. Just from here, just drag it here and provide the parameter values here, like image input layer to design a filter in CNN convolutional 2D layer. If it is a 3D image, then convolutional 3D layer it will be. Huh? And here you can provide the property values of it as well. Further, after designing your model as a deep learning or machine learning, you can generate a code for that C, C++, and all these things. Just wait a minute. Okay. So further, after generating a code like C, C++ or CUDA code, if you want to deploy on Raspberry Pi, that also you can do. If you want to deploy on GPU like Intel or NVIDIA or ARM, any kind of, there also you can deploy it. So it is a very, it is a good, easy to do all these things. Like I showed you, we have apps also. Use the apps, create models, generate code, and deploy in hardware. So this is the framework, access data. So access data, this is a good thing in MATLAB, that let's say if you have thousands of images or maybe millions of images you have. If you load all images at a time in MATLAB or in any software, your system will be hang, right? Because of RAM, your RAM will be full because of less. So in MATLAB, you can create a image data store, text data store, or a simple data store of any kind of data, and you can extract data as a batches in batches. As a let's say in one batch you are taking 50 images. Like this, data will come as a chunk, and it will goes as an input to your deep learning model or machine learning model. So there is a inbuilt function in MATLAB to handle a large data set and automate data labeling as well. Then train your model, then deploy it in hardware also. Okay. So these are applications of automotive. Okay. If you're someone is working on automotive, so let's discuss that what toolboxes are there for automotive. If you're designing a automated driving car, we have a automated driving toolbox for it. Like here we do some perception, then after perception that you have to decide, then you have to take the actions for automated driving car. Means perceptions means what is in front of the car that you are extracting. For this, you can use a semantic deep learning to label like this using image labeler. So for this we have a deep learning toolbox, automated driving toolbox, and we have a image processing toolbox to work on images. Okay, next we have there is a vehicle dynamics toolbox in MATLAB. Like if you want to design a complete vehicle, plus you want to create a scene for that with some hindrance like on the road, means you can create an animation. Means your whole model you can animate it and you can taste it on the path as well using a vehicle dynamics toolbox. Plus, if you want to do some kind of analysis like where heat flow or less or where heat flow is high, there is a means hypermesh analysis kind of thing. There is a partial differential equation toolbox for it. So in MATLAB, this chassis of this car you can design in any CAD model software which you are using, and you can import it in MATLAB for this kind of analysis which you see here. Further, we have ready-made blocks as well. Like if you have to take the battery, we have ready-made blocks like in powertrain block set. You can use these blocks. You can connect it. Just provide the parameter value and lateral or longitudinal, whatever analysis you want to do on vehicles, that you can do it. So, this is a powertrain block set provide fully assembled reference applications models of automotive powertrains include gasoline, diesel, hybrid, and electric systems. So any kind of powertrain you can generate using powertrain block set. We discussed already in vehicle dynamic toolbox, you can create a scene, 3D environment. Okay, you can create a 3D environment to test your vehicles. Automated driving toolbox, we work if you are working on advanced driving assistance ADAS. So there is automated driving toolbox also. You can use that. Already we discussed. Further, if you have to calibrate your engine of your system, automotive system, so we there is a model-based calibration toolbox in MATLAB, and you can use to calibrate your engine. Okay. Now about the aerospace applications which you can use in MATLAB, you can see that if you have to either design a whole aerospace system from pilot to all components which are used in this, you can design it. There is a aerospace toolbox and aerospace block set for that. You can use this kind of gauzes which are available in Simulink to find out the speed, airflow, and this kind of things. You can see these blocks are also available, or you can animate as in vehicle dynamics. You can animate your vehicle, and there is a in MATLAB there is a Simulink 3D animation toolbox to animate your this fly this planes, and you can visualize that how it's behaving in a 3D environment. Plus, if you want to design a complete receiving and transmitting system with receiving and transmitting system, if you are taking a complete, this is a aerospace modeling with radar detection of flight, aircraft, weather, what is weather, based on that. That also you can do complete modeling using a aerospace block set. There is a 3DOF and 6DOF testing also you can do it. And this model which you see, this kind of examples are available in MATLAB, like Neil Armstrong, which he used lunar model they used first stage of the moon. So this model is already available. So this kind of model means on historical applications also you can design in MATLAB. So Simulink allow you to Simulink allow you to model and simulate a variety of aerospace systems. When modeling aerospace system in the Simulink environment, you can use aerospace block set for that. Okay, this extend the Simulink and enable you to model, simulate, and analyze aerospace vehicle dynamics. You can incorporate vehicle dynamics. You can validate your models of the flight environment, like we discussed that you can create an environment as well. You can design a pilot behavior. You can model the pilot behavior, and you can connect your model to flight gear, flight simulator, to visualize your simulation result. So you can interface flight simulator, flight gear as well. Now about automation applications. This is very important. Develop embedded control and signal processing applications for industrial and energy related equipment. Let's say we have to design a whole automatic power grid system. So we have a physical toolbox for that. You can design your grid distribution, automatic distribution power grid you can design in MATLAB. Or if you are working on industry 4 applications like connection, if you are working on big data here, sorry, if you are, just wait a minute. If you are working on big data, or if you are using cloud computing, or if you have to integrate systems, or if you are using internet of things, this components which I am talking, automation, IoT, and all these things are used in industries 4. So all these things are available in MATLAB to design industry 4 also. More we will discuss about digital twin. It is also called that, which is used digital twin. We will discuss. So here you can use MATLAB and Simulink for a smart industry system design. Use machine data to make predictions, as in machine learning, apply models and simulate to control complex systems as well, and develop and implement the embedded software without manual coding. So as I told that this your real plant, you can design same real plant as a virtually, that is called a digital twin. You can extract data from real plant and you can apply on virtual plant, and you can predict the behavior of your system, that how it is going to behave in the future. And further this kind of machine learning applications which is predicting the behavior, you can deploy it in embedded software and hardware as well. This is a case study of Tata Steel. So Tata actually company. So the Tata Steel Group is among the top global steel companies. They produce the capacity of annual crude steel of Tata is 27.5 million tons per annum. It is geographically diversified steel producer with operation in 26 countries and a commercially presence in over 50 countries. They have this steel plant. So they have 200 cooling towers to cool that this machine where they melt that iron to make a steel. Okay. So there are medium and high capacity cooling towers with capacity as high as 1000 tons of refrigerations they have. So they were facing some issues Tata Scale was looking for a way to improve the efficiency of cooling towers. Why to improve? Because whatever cooling towers they had, they were running with the same frequency. You means let's say that if they required less cooling, then they were not able to decrease that frequency, because it was continuous running with a constant frequency. So here it is written the challenge again: if you can reduce the energy consumption of the pump and the cooling fan, the fan which were used to cool that, the energy will be saved significantly. To do that, we have to install the VFD, variable frequency drive they required to install it. Okay, they use the variable frequency drive, but how to know that when I have to make the frequency less and when I have to make the frequency higher to drive that? That was the main issue. So what they did it to do that, they created a digital twin. Already we discussed the representation of real plant as a virtual, that is called a digital twins model. So they designed a VFD controllers also, and further what they were doing it to optimize this variable frequency controller. They were extracting data from real plant and they were applying to virtual plant and on this VFD controller, and they optimize the parameter of VFD controller using Simulink. There is a some toolboxes there, Simulink design optimization and Simulink control design. After optimizing it, then they used in a real time plant. So this, like this, they solve their issue. So, a digital twin is an up-to-date representation, a model of an actual physical asset in operation, as we discussed. So, how it work in MATLAB? To design a virtual model of your original real-time plant, we have a SimScape family. If you have plant from electrical, driveline, multi-body or fluids, we have all these blocks available. Use that blocks to design it virtually. Further, you can log data from sensors from real plant, and you can use this deep learning and machine learning model to predict the future of your system or your plant, you may say. Okay, I am visible. Everyone is silent, so I am asking if any have questions or something they can ask me. So first of all, I want that my voice is audible. Can we generate embedded C code for DSP processors? Yes, sir. We can generate code for C code for DSP processors as well. When I go to MATLAB, I will show you that we have apps for it to generate it. No, to generate code embedded C, there is a embedded coder in MATLAB. Yes, from MATLAB code as well. There is an embedded coder to generate that from MATLAB code as well as from Simulink both. Okay. Any?
Hello.
Yes, sir.
Audio, you said that in MATLAB audio labels and image labels are available. In which toolbox they are available?
Ma'am, IDEO level is available in signal process toolbox. Let's see that here I showed you, na? Here, this is
Correct.
the IDEO leveler. If I move this cursor, it is showing you this. No, sorry, it is a IDEO toolbox. It is written there. You can see it, right?
Okay,
See,
audio toolbox.
IDEO
And
toolbox.
image labeler are here?
For image leveler, you require a image processing toolbox. So here you can see image processing and computer vision both. Image
Okay,
processing
okay,
and
fine.
computer
Thank you.
vision.
Computer vision toolbox,
Right.
right?
Ma'am. Actually,
Okay,
computer vision work on top of image processing. So when you purchase a computer vision, then of course image processing also will be required.
right. It will be
Yeah.
there, right? Thank you.
Yeah. So meanwhile, if any question you can ask anyone. Okay, I'm going then further here. So let's discuss about signal processing and communications applications now. Okay. So in the DSPN system, let's say that you have to design a filter. We have apps to design a filter in MATLAB. So if I go here, let me show you that app which I am talking about. It's a part of the signal processing. If I click this filter designer, you can use this app to design any kind of filter which is available in a digital system, digital signal processing. Then when you are happy, when you got the desired output from the filter, you can export from here to apply on the noisy signal. So this kind of filter apps we have. Okay, here is the option. What kind of filter, band, pass, all this. Design it. Then you have to click on design filter. Then your filter will be ready. Anytime we have session in future about DSP, then we will discuss more in detail. Further, after designing this filter, here you can generate SDL code as well. There is a filter design SDL coder to generate a SDL code of your filter. Okay. So, if you are working on this kind of applications, you can use this kind of thing. There's a phase array system toolbox in MATLAB if to find out the Doppler effect of your working on radar and sonar data to track the object and what will be a minimal distance to track and find the distance between two objects. There is a phase array system toolbox if you are working on radar and sonar kind of signals, and streaming process is also possible using DSP system toolbox in MATLAB. Let's say that if you have live sensor data, if you want to extract, you can install the hardware, extract the live sensor data, take data as a chunk. Like when you watch YouTube videos, then it is streaming and watching, both are going together. Means you are not first downloading, then you are watching it. So what it works, you can work on live data in DSP system toolbox about signal processing. You can stream it based on the algorithm, or if you are working on massive memo system, so there is a communications toolbox and 4G toolbox and sorry, communications toolbox, LTE toolbox, and 5G toolbox are also available in MATLAB. So you can design massive memo system also in MATLAB.
Hello, Akhilesh.
Yes, sir.
Excuse me. Just I just want to know which how we can know which hardware or the sensors or the actuators can be connected to the MATLAB. Just
MATLAB.
like
Okay.
once we generated a MATLAB code and then generated the embedded code, then we have to get the real-time data through the sensors and actuators.
Right, sir.
So, how
So,
we can know which are the list? Can we have some list or something in the?
sir. For I am going to show you the list how you will get it. Just here type mathworks.com.in. Okay, sir. Another way I will show you through MATLAB how you are going to do it. Just click on the products, and
Right.
when you click, these are the all products available here. Okay. Then hardware support packages here it is given, right? So this is the file exchange hardware support packages and services.
Fine.
Just click on this. Okay.
Okay.
Here you can search, sir, by vendor wise that what hardware do you want. Also, it will tell you that which toolbox you will like if you are working on D space. So D
Mhm.
space related hardware came here. Also, it will tell you that what toolbox you require. See here, it is written assembling coder will be required for this hardware.
Got it.
Okay.
Got it. Right.
So from here you can search hardware which are supported with MATLAB. So here you can see which is the hardwares which are supported just from MATLAB, the hardwares which are supported only with Simulink, hardware which is supported with audio toolbox, communication. So here it is given. Okay, so fine.
Fine. Fine. Thank you.
Next, to interface hardwares in MATLAB, we require to install the support packages. So you can go in add-on, click on get hardware support packages from here, and a new window will be open. To install the support packages, you require an internet connection. Okay. So like you see here, I already installed the MATLAB support package for Arduino, Simulink support package for Arduino. So whatever hardware you want to interface with MATLAB, just search here that hardware name. Let's say I want Android to interface. Means I want to generate some APK file kind of thing. So here is already I installed it. Just you have to click it, and just here you will get an option to install. I already installed, so there is no option to install. And what toolbox required for this? From here also you can search it. And as soon as when you install the that support packages, you will get the library. Just wait. Library for that Android here. It will be appeared like so. These are the blocks appeared after installing the support packages for a specific hardware. So you can use these blocks to design your model and deploy in Android. Like if you install the support packages for Arduino, so these blocks are available for Arduino. If you are interfacing with Wi-Fi or Ethernet shield, or if you have to extract the sensor data, there is unlocked digital pins like this. So like this block. Further, how to interface this with that specific hardware? When you install the support packages, you will get one link here in help like this. If I click on Simlink support package for Raspberry Pi, here is the setup and configuration process how you are going to set up with MATLAB. This is a one-time process only, and these are the some examples based on the Raspberry Pi. So when you install the support packages, you will get the documentation for that. Okay. So in Signal, again, in more in elaborate modeling signal processing and communication system, DSP system toolbox already we
In
discussed
this
provide.
conference, this session is being recorded for transcription purposes.
Okay, just okay, let me check. Sir, if you want to study multi-physics interaction, is it possible with MATLAB? And yes, sir. Sure, ma'am. You can use multi-physics also. There is a special toolbox in MATLAB that is a symbolic math. Let me show you that symbolic math toolbox. What you can do with that. You complete physics. You can study with that. This is in a symbolic math group, and this is a toolbox where you can study physics very easily. You don't require any data. Just write your mathematical equations or derivation. If you want to do it, you can use this. There are some examples also which you here in that using that toolboxes, using physics and all these things. Like if you are working on electrical dipole moment kind of things. So these are the applications. So you can use symbolic math for multiphysics. Okay. So we don't have so much time that I can show examples of all toolboxes, but you can use symbolic math for that. I can explain like this that there are toolboxes available or not. Any more questions if somebody want to ask? Okay, we are going further.
For artificial intelligence, any toolboxes separately?
Ma'am, already I discussed for artificial intelligence. We have a machine learning, statistics in machine
That is okay.
learning toolbox.
Any other more than natural language processing and all? Anything separate for artificial intelligence like?
Not separate for that, ma'am. If you have to design AI kind of things, which we have, that is machine learning, deep learning, test
Yes.
analytics, robotics toolbox. If you have to
Right.
design,
So, robotics toolbox is there. Robotics toolbox, what all will be there?
robotics is there, ma'am, actually. And for mechatronics, there is a multi-body and a semi-scape electrical, which we were discussing before. Like,
Okay.
what do you want actually in AI? Actually, I know that in AI we
So,
use basically machine and deep learning kind of things to design.
right. For smell, sir, automatic smell and all for that also. Because perception is the thing in artificial intelligence, no? One is
Ashish,
mainly perception. So
right,
computer
right,
vision, it is too much is there. Okay. So for
right.
regarding smell, I mean to say smell,
Oh,
touch and all.
that things again, ma'am. What I am saying that let's say that we have to identify the smell, right? So in that
Right.
case, also we are going to use machine or deep learning. We have to train the data first of all, because any AI will not know automatically. So you can train if you have that data set using machine and deep learning. That kind of. I will show you an
Okay.
example.
Right.
Deep learning there later when
Right.
I complete this applications, what applications we can use it, that further I will show you example on machine learning as well as on AI also. AI, I will show you one
Right.
example that if someone is in front of camera, I have to detect that a person is smiling, laughing, or he is angry kind of things.
Okay. Fine.
Facial recognition kind of things. Okay. Okay, fine. So using DSP system toolbox, you can design FIR, IIR filters, Fourier transforms. There are some DSP techniques already we discussed about streaming data, and you can generate C and SDL code also for your data, for your algorithm. Means the model which you design in communication signal to test and validate your model. You can generate C and SDL code as well in MATLAB. Okay. So communication system is used to design a physical layer part of it. So there is a not in communication we have a WLAN toolbox as well, wireless local area network toolbox. And using WLAN toolbox, you can interface SDR hardwares like low. If I'm talking low cost SDR hardware, there is a RTL SDR. It comes only 1 or 2,000. A TV tuner. So if there is only receiving antenna, just connect with MATLAB, and whatever free signals are available in the environment, if you know the frequency, you can log that data in your MATLAB, like FM data or flight tracking kind of things using communications toolbox. So, end-to-end simulation using communication. Now, I'm talking about communication application. So, you can design an end-to-end simulation like we have toolbox for source coding. We have modules available for channel modeling like relay channel, or if you want Gaussian channel, depends on you. And further decoding at receiving end, we have all these toolboxes available. We have SOC toolbox, we have a Sardesh toolbox, we have mixed signal block set, we have phase array system, we have RF toolbox, we have RF block set as well for that. We have phase array system toolbox. Okay. And further channel modeling, we can design any kind of multiple fading channels. Okay, you can add if noise, you can find out the effect of noise. Massive MIMO, if you are working on massive MIMO, that also you can design. You can generate waveforms also using communications. Like if you are working on LTE or 5G toolbox, you can generate waveforms for LTE uplink and downlink waveforms. So we have apps for that also. Like you have to generate ortho frequency division multiplexing, this orthogonal frequency division multiplexing, that is OFDM. So these apps are available. You can use these apps and provide the property value, and signal will be generated. And you can visualize the constellation diagram also like this. So we have apps to generate signals for that also. Already we discussed in MIMO processing, massive MIMO also you can design it. You can visualize the pattern, directivity depends on you. For that we have an antenna toolbox also. Using antenna toolbox, you can design a single array, multiple array, as well as from, if you have an antenna image, from image antenna image also you can design antenna in MATLAB. Plus you can create a Gerber file to deploy in PCB using antenna toolbox. For visualization like eye diagrams or constellation diagrams, we have this visualization app in MATLAB to visualize that kind of things in communications. Software defined ratio, which we were discussing, after designing your algorithm for testing, you can interface with SDR hardwares like Zinc SDR, USRP, RTL SDR. This is a TV tuner which I was discussing about it, or Pluto SDR, where transmitting and receiving both antennas are there. So you can interface it, you can send data from MATLAB, and you can receive data in MATLAB using Pluto SDR.
Sir, can I have a question?
Yes, ma'am,
Hello.
sure. Yes, ma'am, sure, sure, sure.
You said many toolboxes. Just I got one doubt. IoT, Internet of Things, for making such applications. Is there
Okay.
any special toolbox or signal processing? Many toolbox we can use and make it.
For IoT, let's say that for IoT, the important thing is that what application are you going to develop? Machine learning, deep learning, image learning, image processing.
Right.
If you want to develop image processing application, of course you will be required image processing and computer vision. If you are working on machine deep learning, then you require a machine learning and deep learning toolbox for that. That depends on your application, ma'am. And second thing, the three nodes which I discussed about IoT, that we require a data aggregator, we require a interface hardware to log the sensor data on data aggregator, and to deploy model in hardware, we require any platform you can use MATLAB. So let me show you that things. That for data aggregator, we have a thing speak here for that. So to register on thing speak, you require to register on MathWorks. So
Okay.
when you register the MathWorks, same credentials you can use to log in for ThingSpeak. So same
Okay.
here, I'm going to do it. Just wait a minute. It is still opening. Okay. So you can see here I created some channels to log my data on sensor. Not only you can create channels to log data only here, you can write your MATLAB algorithm directly here also. Like I write already in MATLAB visualization. If I go here and if I edit this code, here you can write your MATLAB code and you can display on your website. So here you see one model I created of tidal depth using IoT. I am taking a previous 24-hour sensor data, which you see as a blue here, and next 24 hours I am predicting it, forecasting us actually. I am forecasting what will be a tidal depth in next 24 hours. And that kind of codes
Okay.
you can write it here, you can add it. So we have a ma'am thing speak as well for that.
Fine. Thank you.
That's free for students. So in free version, in a year you can upload 3 million data in a year. Okay. In
Excuse me.
subscription version, you will have a 33 million data to log in a year from sensors.
Uh, yeah, Akhilesh,
Yes, sir.
may I have a question? Just as you're talking about IoT application,
Right, right.
if we just suppose we generate something on the Arduino base system and
Mm-hmm.
write a MATLAB code, and
Mm-hmm.
then how to get a standalone system, just like as you have talked about the preparation
Very
of the
good
Gerber
question
file.
you asked me. A very good question you asked me. Let me tell you how to you can create a standalone application. So first of all, let me tell you whatever depends on you that if you are working on Arduino, are you designing your model in MATLAB or Simulink? First of all, okay. So if you're designing your model in Simulink, there is a .exe file creator. You're talking about
Okay.
as a exe standalone, sir, right?
Yeah, yeah.
So here is application compiler. So let me tell you how
Okay.
it works actually. So here, what you have to do, the main function file you have to provide it here. Let's say it is a Arduino function file which you created application, and
Right.
here you can provide your author name and the version of your applications. After providing this, just you have to click here package or .exe file will be created here. Okay. Just wait a minute. Let me
Hello.
show you that what kind of files you will
Hello.
get. Hello, do you hear me, sir? Hello, hello.
This is we can hear.
You can hear, no, ma'am. Okay, okay, fine. Okay, what I was saying you. So when you create a .exe file of it, you will get the.
Yes.
Just wait a minute. So I have so and next thing what I was saying you how you are going to create an application for that. So there is an app designer in MATLAB. Just open this app designer. Okay. I will show you one app which I created to forecast the COVID-19 patients in India. Okay, I created that app. So how to do this? Just see this app designer app, this app designer application. So what we can do, we can use these buttons to plot it. We can use this button like this axis buttons like this. It is very easy. Already code will be generated here. See here it is generated. Okay. Now further, if I go in a design view here, in design view, and let's say that when I click on this button, then something will be visualized on this figure. So what will I do? Just I will select this. I will go in the callback and add a function block below the call. And here I will write my algorithm. When I
Okay.
write the
Okay.
algorithm, whatever I want to execute it, and after writing this, just I have to click this. Okay, and app will be open, and this will be this path you are going to give in this compiler. It will create a .exe file for you. Now next,
Okay.
before through Simulink, it was not supported to create a .exe file. Now from MATLAB 2028, there is a Simulink compiler, so you can create a .exe file of Simulink models as well. Fine, sir.
Okay. Okay.
Okay,
Okay.
so let
Okay. Then after this, when we get a exe file, then it will be just how we will proceed. It will go to the Arduino controller, and how it will actually work.
Of course, sir, it will work in a Arduino controller because if you have to interface Arduino, na, like sir was talking about that I have to interface Arduino, I have to create a standalone application. So of course, it
Yeah.
will
Yeah.
depends on you that you want to use hardware or without hardware. Both options is available for you, sir.
So once exe.exe is generated, so MATLAB application is not must,
No, this MATLAB is not, it will be not required this.
not
The
required.
only thing,
Okay.
one thing will be required, let me tell you, like when you run a Java program, you require a Java runtime, right? To run C
Right.
program, you require a compiler, C compiler, right? So to run the
Fine.
MATLAB app, you require a MATLAB compiler runtime. That is free. One time you have to
Okay.
install that MATLAB compiler runtime and you can use that. So here you see here one application. Let me check it. Where is that app which I created? Okay. So these kind of apps you can create. I created. I actually log data from every day. I am logging data of Corona patients in India. Here is this. You can see here for of all states and date wise also. I have all this data. Okay. So what I did here in this case. Okay, it is still opening. So here I use the plots, state-wise, confirm, and all these things. In code view, I wrote the code as simple as it is. Now, when I
Okay.
run this, it will ask me the file path of that Excel file. Let's say this is the Excel file I am giving the path.
Okay.
Actually, after a long time, I am running app, so it will take.
Okay. Okay. It will get a data from the Excel file.
No, yes, it will get the data from Excel file. The Excel file. Then here, what I am doing, confirm with after actual confirmed patients and active patients, and here is the state wise, and here is the prediction. Here, see what I did. Let's say that I have to predict that what will be a corona patient. I mean, in India in May. In May, if
Got
I
it.
want to predict till 31, what will be there? So just there is a two. One is poly and one is exponential, which I created predictive model. So actually, it will take a little time. And when I click on this present state, it will predict the present state of states as well. So and further, using application compiler, you can create a .exe file. So you see here, this is a present state.
Okay. Okay. Nice. Nice. Good.
And this is a confirmed, and this is a see forecasted. So by 31st May, if I the data which I use, if I use these are the count of patients which will be happen.
Oh my God.
Right?
Big number.
It is big numbers, sir. It is on present state, but already government is taking lots of efforts, so it will not increase like this. Actually, it is based
Yeah.
on the present state. Actually,
Okay. One more thing. You were talking about just for the Gerber files.
Gerber files, right? Right, sir.
Yeah, that is for the PCB fabrication or the final
Right, right.
design that you require.
Ji,
So,
ji.
is there is any anything available in MATLAB also to generate a Gerber file?
In MATLAB, sir, when you design the antenna, let me show you that type antenna designer.
That's a
Or you can
communication
write,
application, right?
sorry, sir.
That is in the communication
No,
application.
no, 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 no. Antenna designing is in a antenna toolbox, sir. Actually,
Anti works. Okay.
group is signal processing, but it is in a antenna toolbox. So here, what you can do, you can design using this app your antenna. Then further, you can generate a Gerber file of that antenna. Only for the antenna it is.
Okay, for antenna only, not all.
Not for everything, sir. For antenna. There is an option to
Okay, it's okay then.
generate a
Okay then.
Gerber file. Just this here is it is asking you click new. When I click on new, here is the all antennas which are possible. And let's say that if you don't have antenna, you require some antenna which is not available in this. So just take a
Hmm.
picture of that antenna, and you can picture only you can generate antenna in MATLAB. Okay.
Okay, okay,
So
that's
these are
fine. That's fine. But
from here you can design antenna. I'm not
but
going to
I
deep.
just it's not in generic mode is available. It is not for all the applications.
It is not for all, right?
Okay,
That
okay.
this which are available only this kind of antenna you can design, sir, using this app,
That's okay. Okay.
like a spiral and dash family. So what I was saying, let's say if you have some other antenna, you have to take a picture of that, and you can design antenna. From picture you can extract the parameters actually in MATLAB. Fine, sir.
Fine.
Okay, okay, I'm going there. And there is an option that what will be a material strength and what will be insulation power, frequency, all properties you can define in that app.
Okay.
Yeah. So in communication, you can design a model and simulate Bluetooth as well. You can interface with your Bluetooth device with MATLAB as well, or you can interface with the smartphone and with your Bluetooth is available. And about W which I was talking, model and simulate, you can combine the physical layer and Mac layer. So medium and access control layer, which is available, medial and access control layer. So these layers also using WLAN toolbox, this kind of layers also you can design it. Okay, about the physical modeling, we already discussed we have libraries for power system, we have libraries for electronics, We have libraries for electrical, we have libraries for fluids, we have for multi-body. Multi-body is for mechatronics and electronic both. And if you are working on translational or rotational kind of mechanical system, we have a drive line also there. So let me show you just that library which are available for physical modeling in Simulink. So here, this is a part of here. So see, these are libraries for driveline, electrical fluids, multi-body, and some utilities are there. So here you can see, if you go in foundation library, so here you can see we have blocks for electrical, gas, hydraulic, isothermal, magnetic, mechanical, moist, all this from different domains. So we have blocks like this, gaseous blocks. If I expand it, so you can see some blocks which are available. Just what we have to do, just to connect all these blocks and provide the property value and run it. And further, if I go in electrical, right now, Semiscape electronics and electrical both are combined together. These are the electrical blocks which are available here. Like these are control blocks, and there is a special technology also blocks available like electrical drives. Okay, these are the AC drives, DC drives blocks are available. And if you are working on renewable energy, then we have a PV array here in MATLAB. Or if you are working on wind energy, then there is blocks for wind energy as well in MATLAB. So these are the physical modeling blocks which are available. And this is a drive line. Okay. So, semi-escape driveline used to design a rotational and translational mechanical system. Semi-escape electrical is used to design electronic, mechatronic, and electrical power systems. Semi-escape fluids is used to design fluid systems. Like if you have to design any petrol pump station kind of things, what will be a flow there, what will be a pressure on that float, what will be a rotation of that, all these things you can design it. And CVSK multi-body, if you have to do, if someone is working on mechanical 3D modeling, like if you have any CAD model, you can import that CAD model MATLAB, and in further you can do some analysis like to controlling that model, or if you want to do some kind of mesh analysis, that also you can do it. So there is a just to that kind of things also you can do it here, 3D modeling. Further, this is a case study of that physical modeling. Lockheed Martin, they wanted to launch a spacecraft actually, so they are using a multi-domain power system model they use. So their challenges was that simulate the Orion spacecraft's power system to validate the design, test fault conditions, and verify the performance of that. So what they use the Simulink and Simscape electrical to model solar arrays, batteries, and the complete system. Means before they went for the physical modeling, they tested and verified in the Simulink, and they required different domain blocks like Simulink. They required electrical blocks, they required mechanical blocks. So all these modules which are available in Simulink, you can interface with each other on a single platform, that is a Simulink. So they already, and the results which they got, that third times they got the library of reusable components, establish the low level coding minimize. So low level coding, so which they had to do it, that minimize it using that. So there are some more in Volvo. They wanted to design equipment before building the physical prototypes. Again, before going for a physical prototyping, they design virtually in Simulink. Again, they use Simulink real time, hydraulic, mechanical, all this toolboxes. So as I was discussing about model based design, like hardware in the loop, software in the loop, they did all testings in Simulinks, and they went for the hardware for that. So in image processing and computer vision, what we can do, first of all, you can interface with OpenCV, you can interface with Python, you can interface with C++ image processing programs, because there is a APIs in MATLAB which is used to interface with that languages if you are working on image processing. Also, you can automate your tasks, you can accelerate your algorithms also. Plus, you can deploy your algorithm, or you can run your algorithm on NVIDIA GPUs, clouds also. or for when your algorithm is ready, you can deploy in FPGA or ARM kind of hardwares as well, using image and signal processing. Let's discuss what applications are available, some specific applications in image processing. Like this is very important, camera calibration. Using these apps, you can calibrate your camera. You can extract the properties of your camera. Based on that property, you can modify your distorted image as a original how it looks like, same like this. See, before it was distorted, we use the camera calibration, we got the properties of camera. Based on that properties, we enhance our image like this. So this was a lens distortion, removing lens distortion. Using camera calibration, you can find out the camera position, where camera is your standing, what is the angle of your rotation of your camera in space, and fixed objects, where is their distance you have to find. You can use the to do this kind of applications, to extract this kind of features, you can use camera calibration app there. Already we discussed image and video labeling. You can use this image and video labeler to label your images here in different parts. And segmentation, let's say if you have to segment tumor, if you have MRI images or CT scan images, let me show you how to visualize that kind of data. Let's say I have a CT scan image, okay, and I have to visualize that CT scan images as a 3D.
This session is being
So hope I am audible for everyone. I think it was disconnected or something else.
Yes, yes, it is audible.
Okay, fine. So what I'm doing, this value we were one app is there to visualize CT scan or MRI images. Not only for visualization, using computer vision and image processing, if you have to find out the what will be a volume of your of lungs there, or if there is tumor, then what is the volume of that tumor. That kind of things also you can do it. So here, what I am going to do it. It is still opening. I'm going to import that images from workspace. Let's say this. So here you can see the MRI CT scan images which I have. There are 380 frames. Slices are there. Okay, 380. XZ slice, YZ slice, and this XZ slices. So right now it looks like this. Okay, as I told, is a CT lung image which I was discussing. So here you can see, you can visualize it. And this is the lungs. If you have to find out the width, height, area, and or volume of these lungs, you can use image processing. There are direct inbuilt functions available to do this kind of process. All this. So it is a city bone. So here you can see the bone part of this. So depends on you what you want to visualize from that images. Okay. Okay, in image segmentation, already we did, you can segment that images. Again, we have apps there. You can write your algorithm. If you don't have time, then use the apps to segment your images. In image processing, you can work in medical images. You can work on 3D image processing. You can work on video processing, or you can, if you want to deploy in hardware, you can use embedded with.
Hello,
There is, yes, sir.
can
Yes,
I
sir.
have a question, sir?
Sure.
You were telling that so many things are available for in image processing and computer vision, like segmentation and all, right? We can also write our algorithm, but it is
Right.
not that it takes time only. It is not something is not available, so we can write also, no? So can you
Sure.
tell specifically what can be the limitation of this? So many things are there. So my question, you understood?
Your
Hello.
question is hello. Yes, ma'am. Do
My
you hear?
question is mainly, see, lot of research is going on, okay,
Mhm.
on image processing, computer vision, many things, right?
Mhm.
But
Mhm.
so many things are available. The way you are presenting, we see the great applications, okay.
Mhm.
But you are saying segmentation or any other thing. If it is difficult for us to write, we can use the app. But there
Right.
are certain limitations also. For that purpose,
Right.
also we write our own. That can you focus one or two at least, which you came across?
the limitation is there, like say let's say that I am going to use fuzzy logic. Let's say that I am going to use this apps to design a fuzzy logic in this case.
Okay.
I can design the complete fuzzy logic, but I can't generate a code from here. The first limit is
Okay.
you can say I am not able to generate a code. I can design logic, I can create, I can export it as a FIS model. Further limitations are there that let's say that I am going to use um, here color thresholding.
Okay.
So
Maybe in segmentation also, we can have different algorithms. Maybe
right,
already a number of algorithms are taken care, but still, if you want any specific or your own algorithm, you want, right? Then
right.
again, we can write with
This
it.
is the limitation, ma'am. Actually, I am using the segmenter app as well. So see here. See, if your algorithm lies between this algorithm which is given here, like active contour methods or graph cut method, then it is fine. This app is fine for you. But what
Right,
apart from that, if you are going to use other algorithms, then you can you
right.
are not
Hybrid algorithms,
you can't use this app
like
for that.
hybrid algorithms, etc. Right,
Right, ma'am. Right. So
right,
in that case,
right.
you have to develop your algorithm.
Correct. There is
Or,
a need
or,
now. Right. Fine.
sorry.
Thank you.
Or one thing more, ma'am, you can do it. That was the
Right.
app, right? So there are
Uh,
more than that app. Like this, I am saying that was a part of a image processing. I will just click on the image processing. I want to know
Right.
what more I can do using image processing. Just I will click on functions. Okay.
Okay.
So like if you have to read and write image data, then you can use these functions. If I
Correct.
click on any function, there is a documentation with examples as well, how it works for every function.
Correct.
So
Right.
yeah, here group wise, all functions are given. If any algorithm not exist in these functions when you click it, then maybe you have to write your algorithm. And
Right, right. There is a need always to write. Thank
right.
you.
Hmm.
Fine.
Only benefit of using these functions is are that it is already developed by someone. So why we are going to develop it again? Just use it directly in your algorithm.
Right, right. That
Yes,
is true. And rich variety of functions, not just like that also. Rich variety is there.
yes, ma'am.
Fine.
So after developing your algorithm, you can generate a C, C++ code, SDL code of your image and computer vision also. And you can deploy in FPGA hardwares, or if you have ASICs, ASCII's hardware system for real-time applications. Some other applications of MATLABs are like complex logic if you are working, or discrete event simulation if you are working, or if you are working on system engineering, we have a system composer for that also. This system composer is introduced for MATLAB 2019B. Large scale modeling if you are working, that also you can do, or if you are working on geo reference data, like if I have to represent that forecasting of COVID patients on map, where will be count based on the location on lat and long. So if you're working on that kind of data, you can use a mapping toolbox in MATLAB. We have a mapping toolbox for that. Okay, now next, these were the applications of MATLAB which we discussed, that which you can do it. So actually, MATLAB is very broad to discuss, but I tried that whatever possible applications which is going on right now, I discussed already that things. Now I will show you some examples on machine learning and deep learning, how to do it. So first of all, let's say that what is machine learning, and then I will show you one application on machine learning. Then we will discuss what is deep learning. Then I will show you one application on deep learning as well. So machine learning teaches computers to do what comes naturally to humans and animals. Learn from experience means the things which human or animals can do, that facility we give to machine, that machine will do for us. Second thing, machine learning is just algorithms. That's all. As well as in machine learning, we don't require any predetermined equation. That's why machine learning is very famous. Let's say that the what is why we do analysis on data or on mathematical equation. Our main aim is to make the relationship between dependent and independent variables and estimate the parameters for that. This is our main goal to create. If I'm creating any kind of predictive or forecasting models. So if I'm working on mathematical equation, let's say I have a differential equations, integral equations, it will take months and years to solve that kind of equations. So that's why machine learning and deep learning comes in the picture, that we don't have to write any mathematical equation, or we don't have to extract any parameters. Machine learning will learn your machine learning will learn directly from your data. Just you require a data. Now because of IoT sensors, we can log data from anywhere, whatever data we want. That's why. So already we discussed machine learning applications as well, where we can use it. So machine learning is two types: supervised and unsupervised learning. In supervised learning, again, machine learning is divided in two parts: classification and regression. Okay. So in classification, it is a discrete learning. Regression is a continuous learning. Just wait a minute. I'll just okay, fine. No, no, no. Okay, supervised learning, it is divided in two parts. What is supervised learning? In supervised learning, first of all, we have inputs and outputs both. Let's say that you have a supervisor, he sent you in the market and he told that collect the input from the market. He went in the market, he collected inputs, and your supervisor is will give you a output based on the input which you collected. So you have a inputs and outputs both. Again, in supervised learning, it is divided in two parts. Classification and regression. Classification is a discrete learning and regression is a continuous learning. Discrete means you will take some inputs and you will assign one class name for that. And in regression, for each and input, you are getting a numeric output, like load forecasting. In classification, let's say that a group of samples will be in a good class, or it will be a bad class, or it can, if it is a temperature, the low, high, and medium group, like this. Mhm. Unsupervised learning is a clustering. Clustering means you don't have any output. You don't have any supervisor. You collected data, then you are going to find out a pattern based on that data. What is the pattern? Exa example of clustering is in your mobile. You can see it, like when you take images from your camera, or if you load images in your mobile, automatically your images are clustered as a places, as a names, or as a cousins, and like this. Okay, so that is a part of a clustering. Or if you search something on Google, when you type a word, based on that word only, Google will show you a result. So that is a part of a clustering. Okay. So these are the algorithms which you can use in machine learning.
Sir, can I ask you a doubt now?
So
If
sure,
you
ma'am.
don't mind.
Ask please.
I don't know whether related or not. You know, Arugya Setu application we have downloaded, right? Uh, in the Arugya Setu application, machine learning and deep learning is used, and automatically it will update whenever a patient or anybody comes with symptoms, I think. Can you just throw some light how exactly this machine learning or deep learning is used in that, if you can?
No, their machine and deep learning is. Are you sure about that? I think they are
It is used.
clustering kind of.
Artificial intelligence, and no, they were telling always
No,
it machine learning and deep learning is used.
no. Actually, let me tell you what is used there. Their clustering is used actually. Machine learning is
Okay,
used.
okay,
That
clustering.
is part of a clustering.
Okay,
When you fill
okay,
that form, there is the option to fill that form, right? When you
right.
fill the form, it will there is a some classes that when you fill this form, then you are moderate, or
Uh,
or it can be a normal, or it can be affected, right? So what it is
right.
happening? when you are filling that form, your data are automatically clustering,
Okay.
right?
And it is
And
updated also, no? The data is updated also, not static, dynamic also it is.
ma'am, they have a database too, है ना? They have database online where they are updating that data.
Right. They say that when you go in a group, any
हाँ,
person with the symptoms, it can also detect and
yeah,
tell
yeah,
some
yeah.
precaution.
What you will do, your Bluetooth will be on always. Okay. So
Right.
when what you are near with some infected person, if you are near with some infected person within the range of Bluetooth, then
Uh,
it will give you a signal from to you, a red signal that and sound that you are in a danger zone or
uh,
something like that.
how it is doing because of this machine learning, no?
They are doing,
Because it
ma'am.
is updating the data. It is updating the data with the new person, right?
Right, right, right. This is
Maybe
updating
that,
the data
no?
as well. They have
Uh,
a data set as well. Second thing, like
uh,
I feel that, let's say I am infected, I feel that data. So always on my mobile, it will be classed as I am infected. When I go somewhere near to someone who is not infected or infected, so through the
okay.
connection, it will send him a message that you are near some infected person, something like that.
Acha. Okay.
Mhm.
Fine.
So here,
Thank
these
you.
are the algorithms in machine learning and in clustering. The problem is that based on my data, how will I know that which algorithm will be a best for my data? This is the first question, that how will I know? Let's say if I am working on support vector machine for my data since 6 months or 1 year, and my accuracy is not giving which I want, means the result which I want. So my 1 year or 6 months will be ruined for that. So the good thing is that do a reverse. First of all, identify that which algorithm will be a best. Now, again, the issue is that there are lots of algorithm. How will you identify that which algorithm will be best? Even if you start working on each algorithm one by one, it will take 1 year to do this, to identify that, to compare that. It can be a regression or it can be a classification. So in MATLAB, the things which you can do in 1 year, MATLAB will help you to do these things in 10 minutes only. How to do this? Let me show you one example. This example. So this is a machine learning workflow. It works like this. First of all, this is the workflow. Then I will show you the example. Action and explore means you require data. Your data can be in file, or your data can be in data phase, or you are getting the live data from sensors. Then when you collect the data, is pre-process that data. Means you are working on messy data. Maybe there will be some missing data, maybe there will be some noise in your data, maybe there will be some outliers, so you have to remove all that kind of things to do that. Okay. Then next is to remove the redundant data which you don't require to train model. So in MATLAB there are functions like PCA and all this kind of things. Further, you have to extract the features from your data. When you extract the features, like if I'm talking about time series data, then what can be a feature for time series data? It can be a mean, it can be standard deviation. If you have a rotational data of a motor from motor, then you require a frequencies also. If a peak matters, then you require a peaks also, so you have to convert in a frequency domain as well. You require a frequency features as well. When you have all these features, then you are going to rank that. To rank that features in MATLAB, there is a ANOVA, analysis of variance, you can use to rank the features with the features which are more responsible to create your model. After doing this, write your algorithm, optimize your parameters, and validate it. This validation is very important. Without validation, your model is useless. Further, you can create a desktop app .exe file, or you can interface with other languages, or you can deploy in a hardware as well. Some So I'm going to show you one simple example first of all. Then we'll go one more example there. So this car, okay, some noise are coming. Someone is okay. I don't know from where this noise is coming. Okay, I have this car. Okay, let's say that I am giving some weight on car and I am accelerating car and moving my car. So I am giving some displacement to car, and based on this data, I have to predict that what will be a mileage on my car. Okay, I'm giving some weight, some displacement, some acceleration, and I am predicting what will be a mileage of my car. First, what will I do? I require this data sets, all four variables, and to create a model. When we create a model using machine learning, then we can predict that we will give these three predictors as an input. It will predict that what will be a mileage. Right? Just okay. Fine. So these things we are going to do it. So let me load that data and do it this process in MATLAB. So what we are going to do first, we are going to load that data in MATLAB. Okay. So this data I have in one folder, that is example. Okay. I have that data as a .mat file. So I'm going to load that data. See, if you have any file, if you don't know that how to load that data in MATLAB, so here is the import tool. Here you can just click on this import tool, and this file formats which are supported with MATLAB. And further, just select your folder. Let's say I am going to select by predicted, something like that. If you select this. Any file, it can be a text file as well. This is the data. To import this, just click on this green tick. Your data will be imported in MATLAB. How you are going to import, you can choose it from here, and you can generate code also for that, like this. Okay, to read the data as a table, we use read table command. Okay, we were here. So first of all, the four variables I am going to use, three predictors and one is target. So what I'm first of all, I will create a matrix of it. First, I'm going to take acceleration. First column will be acceleration, and second, I am going to take displacement, and third, I am going to take that is input, that is weight, and the last column will be output, that is mileage, MPG. Okay. Now you see here. Here you see here. If I open this. So this is by acceleration, this is displacement, this is weight, and this is by output. Now you see there are some missing data, right? NAN, NAN, NAN. These are missing data, not a number. So we have to remove this missing data, or we have to fill this missing data of mileage. So for this, what we can do now, see the capabilities of live script now. How you can use this live script for pre-processing as well. So what I am going to do here, I will go in insert. In insert, if I go in task, there is a some task like for data processing, clean missing data, clean outliers, or find local extrema, remove trends, or smooth data if you have not smooth data. So I'm going to do clean missing data. A template will be opened. Now I have to select that data where there is missing. That is a MP, that is mileage of car. Okay. Now here is the option: are you going to remove or fill that missing data? I'm going to remove, fill that missing data. And here is the algorithm. What algorithm are you going to use this? I'm going to use moving median method. Okay. Okay. And my output will come here. Let's give the name MPG in a small letter. MPG. Okay. So now, if I open this MPG from here, now you can see there is no data. All are filled. Wherever there was missing data, that all are filled now. Further, in this case, if you want to do some modification, because this is a template here, you cannot modify it. Just convert this as an editable code. If I click on this, you can modify now as well. This okay. Now I have that data. Okay, field. Now, so that field data is in MPG. Now, if I open this matrix, now you can see here. I don't have only one is missing there, but otherwise remainings are removed. I don't know how it appeared. Otherwise, this is removed missing data where an AN was in remaining. Further, you can use different algorithms also to fill that missing data. Which still missing data is remaining. So I don't have time to do lots of process on this. So this is a part of a regression, and this is a part of a machine learning. I will go in machine learning and I will open this regression learner. Okay. So same way there is a classification learner as well. You can use a classification also for that. So app will be open like this. And from here, I am going to start a new session. Just I have to click here and I have to give that matrix as an input. Okay. See here, column 1, column 2, column 3 are as predictors, and last column automatically it is selected as a output. Okay. Next, validation. So there are two ways to validate: cross validation or hold out validation. If you have big data, use hold out, otherwise use cross validation. So in cross validation, you see it is automatically divided in 5 parts, means you can increase this folds also or decrease that. So fivefold means my all data will be divided in 5 parts, and 4 parts it will train it, and last fold it will validate. What is validation basically? After training a model, you give a new input, you predict predicted output and original output, which you compare. That is a validation. Means after comparing whatever accuracy are you getting it. Like this, in this case, it will do 5 times, and the accuracy will be an average of that 5 accuracy. Hold out validation, you can hold out some percentage to validate it later after creating a model. Or no validation, if you don't want to do validation, then no validation, and later you can validate it from your Excel file or text file wherever you have data. Now start the session. And if you have big data, we don't have big data right now. If you have big data, then you can use parallel computing also. So what it will do, it will iterate your iterations and data on all cores which you have in machine. So you see here, column 1 was acceleration. Okay, so x-axis is acceleration, y-axis is response. It is showing a relation. So you can see if I am increasing and decreasing acceleration, there is not so much effect on my mileage of car. It is so much random. And now you see, if you have this kind of data, you can't generate a mathematical equation. Again, that's why we are using the machine as well for that. Now see, column second was displacement. Now you see when I am increasing the displacement, when I as much as far I am going with car, my mileage is also decreasing. So this is important input to create by model. Third was weight. So as much as weight I am increasing it, my mileage is also decreasing on the car. So the here is a feature selection. If you don't want some features, you can untick it from here, and further reduction you can use PCA also from here. Now, this all are algorithms for machine learning, linear regression, regression trace, support vector machine, Gaussian process model. Okay, but I don't know which algorithm will be based. So I'm doing reverse engineering in this case. I will identify that which algorithm will be a based, as well as it will create a model for this also, and we can generate a code if I have to do further modification in that code. So I'm going to choose all and I will click train. So what it will do, it will
Being recorded for transcription purposes.
hello. Okay.
Hello.
So now you see one by one, it is training on all. I think someone mic is on. Please the mute if mic is on actually because noise is coming. If you have any question, then only unmute it. So you see here right now, still Gauss training is going on, and the best means the root mean square error will be less. It will be highlighted. If it is less than others, it will be highlighted. So right now, Gaussian process regression model is perfect. Training is done. Gaussian process regression model is perfect, and here is the error which we see. So this is a response with input variables. The blue is a measured one, and the yellow one which you see that is predicted from model. So you can compare your result. Next is predicted with actual plots. So here you can see that this is a zero. This is a predicted response with true response, black line. So when predicted and true response are equal, you will get a straight black line. If your samples maximum samples lies on this line, means your model is perfect. Okay. Then there is a error plot. So this is a zero line error, zero line error plot because this is residuals with true response. So when your samples lie maximum on this, means your model is perfect. So this error which you see that will be outliers. To remove that outlier, already you can use live script. There was an option to use that outliers as well to remove that outliers. When you are happy with it, everything is done. Then further you can generate a function for that. This is a user defined function. So this is a function name in a square bracket. How many inputs do you want? Model and validation root mean square error value. This is your function name, user defined function, and here is the input arguments. In this case, that matrix which we created AA. And below here the all processes written that how you are going to do. Now, from the function which is used to train this model, fit RGP, fit regression process, okay? Gaussian regression process. If I go in help here, I selected, and now in the help, if I click in a browser, the things which we did it right now, same thing you can do in a single line. See, this is a part of a statistics and machine learning. If you go in a function, you will get this function, and there are other functions also. Fit RGP table. What kernel function are you going to use? Fit method, what are you going to use? Predicted method, what are you going to use? And standardization of it, means normalization between 0 to 1. And you will get the model here as a GPR model. So in a single line, it is done here. In our case, first we find out that what algorithm will be a best, then we generated a code for that. Further, if you don't want to do modification in your code, you can export this as a model. See, train model. Okay. So here is my model, trained model. It will appear in a workspace. Okay. Here, trained model. Okay. So this is my model. I will use this model for prediction. For prediction, I require three inputs: acceleration, displacement, and I require mileage is the output. I require a weight. Okay. So to predict on new data, you have to just use like this train model, predict fun, just a few, write few alphabet and you use the tab. So it will show you a whole function. So here I'm going to put first acceleration. Let's say acceleration is 50, and displacement, let's say it is 400, and weight I am going to give a 3500. I want to predict what will be a mileage on this. So if I run this model, so mileage is 18.3903 miles per gallon. So in this case, the this mileage was miles per gallon. So this is my prediction in this case. So like this, you can use machine learning. So here you saw that we didn't require any mathematical equation, or we didn't created any mathematical equation. We use the machine learning, we created a model, and we can use this model for prediction, further prediction on new data. So you can use on live data also. This. Okay, any question if someone want to ask?
अच्छा एक बात सुनो
आपने म्यूट रखा है?
हाँ ये
Okay, if you don't have question, then I'm going for further. Fine. Okay, now one example I will show you of deep learning, how to do access deep learning. Okay. So first of all, using a deep learning, I am going to use a CNN. I am not going to describe so much about CNN because of waste time. Just see the model how I am creating this. First of all, we have to create a image data store of your images. We don't have to read all images. So like what you have to do, just give a folder name like this. Here I did it. Folder name, and in main folder, just create a subfolder by class names like anger, contempt, disgust, fear, happy. This is the gesture of your mind. Okay? So based on this subfolder, save that specific samples only. Okay. If you have anger sample, save in this subfolder. If you have contempt images, then save it in this subfolder. Like this, you have to create, save your images. After doing this, there is an inbuilt function in MATLAB to create a data store, that is the image data store, and this is your main folder path. If you give the command including subfolders true, so it will lead the subfolders also, which is available in the main folder. And for the class, already subfolder name will be a class of your samples. So what you have to do, label source folder names. If you give this function, this property, then it will take it subfolder names as a class. Further, again, I told validation and training both are important. So by using this function, we are splitting that data set as a training and as a validation. 0.8 means that 80% will be used for the training and remaining 20% will be used for validation, and randomly it will take simple for that. So just what I'm going to do it, just I'm going to run this. So if I run this here, it will read all images path. See, just wait a minute. Okay, it will read all images part in a, as a DS. It is still executing actually. When it is executed, then okay. Since long time actually MATLAB is open. Since yesterday my machine is open, so maybe RAM will be full, so it is a little bit slower. Just wait a minute. Okay, it is executing now. Okay, now we have this data store. So if I see, if I type this IMDS, here you can see a path of all samples, images which we have. Total 1000 images we had. So 978 plus more than that images we have. We created a image data store of it. Okay. Now, if you give this command, imds dot count each label, so it will tell you that how many samples do you have. So what in every subfolder. See, what you have to do, like anger is 135 and contempt is only 52. So there is a issue. What you have to do it, you have to take a number of samples almost equal. If I use surprise 249, then whatever someone will come in front of camera, what it will do?
In this conference, please note, this session is being recorded for transcription purposes.
So more it will. Yes. In, fine.
In this conference, please note, This session is being recorded for transcription purposes.
Okay, you go again. Someone point. Okay,
Fine. Okay.
actually some noise are
Actually,
coming,
some noise are coming.
and it is
And
if
it is,
someone is
if
not
someone is
unmuted,
not
then, if someone is not unmuted, okay, I think
I think
still some
still
noise are
some noise are
repeating my voice.
hitting my voice.
So here you can
So
see
here
this
you
is
can see.
layer. Okay, so
Okay.
each layer,
Layer.
let me describe this.
Let
Image input layer
image
is
input
zero.
layer is
Give the size of the images. So here, size of image is 48 into 48. It is actually a gray image. If you have color image, then it will be
In
something
this
m into n
conference,
into
please
3.
note, this session is being recorded for transcription purposes.
Another layer is
another layer is
convolutional 2D layer.
layer.
Convolutional 2D layer is
Convolutional
used
2D
to
layer is
convolute your image and
your
extract it
image
as
and
text file.
text
So
file.
here you can
So
see
here you can see convolution.
the filter size
The
is 3
filter size
here
is 3
and
here
number of
and
filters are
number
8.
of filters are 8.
Number of neurons.
Number of
How
neurons.
convolution work?
How convolution
Convolution.
convolution.
So
So
like this.
like this.
Here we can see
Here we can see
it's 4, 3
4,
into 3,
3
3.
into
So in
3,
this
3. So in
we
this
see filter size is 3,
filter
right?
size is 3, right?
How convolutional
How
3
convolution 3 fit
filter will be created. What it will do, this is let's say image. It will take a 3 into 3 matrix from the image, number of pixels. It will convolute it and it will give to the next layer. As it will be assigned like this. Okay.
This conference.
So this then again it will go for the next 3 into 3, then again next to 3 into 3, and how many times it will do. Here I assign the number of filters. Okay, 8. Okay, so this is a convolutional 2D layer, and this is batch normalization layer. If you want to normalize your features which are extracted from convolution, you can use batch normalization layer. ReLU layer is a linear rectified unit, means to make any negative features as zero, we use linear rectified because we don't require negative features. Further, we have a feature of 3 into 3. If you want to reduce this feature into 2 into 2, you can use max pooling layer. So maximum features we want 2 into 2. Okay. Then except this, these layers you can repeat it like this with a different metric size, filter size. Like here you can see before number of filters were 8. In this case it is 16, and then it is 32. You can repeat this. And these last three layers are very important. As we had 7 classes, we provided in fully connected layer as a 7. Short max layer is used to find out the probability that what is the probability in that image that person is smiling or laughing. Based on that probability, the classification layer will predict that what is in that image. This layer either you can design like this, or you can use this app to design that layer. Just wait a minute. To design using app, here is in this is a part of deep learning. So there is a deep network designer. So you can use this apps to design your layer. Just drag and drop. Then when you are happy with that, when you are satisfied with that, then you can export from here to train that layer with data set. Okay. So this is still opening, and further in this, after designing this layer, I am going to execute this. Next step is to define the options that what solver are you going to use. It is is the gradient and what is the initial learning rate? Like as a human that हम लोग जितने स्पीड से पढ़ते हैं उतना जल्दी भूल भी जाते हैं और accuracy will be less. When we study slowly in a relaxing way, then our accuracy will be high for long duration. So when you decrease this initial learning rate, accuracy will be high. When you increase this initial learning rate, then accuracy will be low. But be careful that maybe there can be a overfitting as well. So you can see you can, if you have any pre-trained model, you can import from workspace. Like I was talking about tensors and keras and another pretrends. You can modify in this app that layers, or you can start from the scratch. So just what you have to do, just you have to drag this layer. Just provide the image size here. Then further you are using convolutional 2D layer. Just provide drag it, and this will be not required. Is this one? So like this you can drag all layer. Okay. Then to arrange this that all layer. Then further. You can export this layer from here, export. Okay, or you can generate the code also, and you can use this app to train your model. We were here. So after defining the options, and here also, how many epochs do you want? 10. 10 epochs means or full 10 cycle will run. In that case, during training, it is a back propagation. Whatever your equation weight is coming, the weight will be optimized. To train this model, we use train network. This training samples, and these are the layers which we defined here, and this is the option which we created here. Okay. Now, if I run this from MATLAB 2020A, you don't have to write code. You can use app to do these things. So there is an app to train a complete model. So it is training. It is detecting my GPU. If I have a GPU, automatically it will run on GPU. So as you see, there are more than thousands of images. So it will take a little time to do this. So here it is showing that GPU. I have 3.5 computing capability. In future release, they will remove that capability. They will use higher version for that. So, like this, app will be opened where you can visualize your process of training of deep learning. So, it will learn for 10 epochs. Okay, it will learn for 10 epochs. After training this model, your model will be saved here in a convoluted. Okay, then to classify your new data, we use classify and my deep learning model, and here will be your input image. Okay. So this function we use to classify this. So still training is going on here. First epoch started like this. It will learn for the 10 epochs. So you see using GPU how fast it is training in MATLAB, right? So almost it is 100%. You can see here. Second figure you can see losses are after 10 epochs it is zero. Okay, and weights are optimized. Total number of iterations is showing 60. 60 means number of batches is called number of iterations. Okay, so this is 60 iterations for 10 epoch. Fine, you can modify that iterations also. Okay, after doing this, what I am going to do, I am going to read one image. Okay, and I want to classify that what is available in that image. From data store, I am reading it, and from here, you see here, I am reading that data one image. I am classifying that what is there in the image. Then I'm showing it image as a title. I am giving this class that what is detected from that image. Okay, so here it is class anger from that image. See, it looks like anger, right? Now, if you have to validate it, then what we have to do it, classify which we data, I mean, which we save for the validation. Okay. So we are classifying on validation samples. We will get the output as a predicted output, and original output is already saved. We are comparing that output wherever predicted is equal to validation. This condition will satisfied. We will get value 1 logical index. If I sum that one, it will tell me how total true validation is done. Divide by total number of samples, it will give me the accuracy. And further, accuracy here it is showing 99.99 means 99% perfect training. Further, if you have to interface with a camera, like I am using IP camera. If you know the IP address of your IP camera and password also, if it is password protected, you can interface that IP camera using MES acquisition toolbox in MATLAB. After interfacing, here you can see I am running. I can't show this actually remotely, so I am not going to run this code. While true means it will run for infinity time. Then from this camera, I am taking a snapshot, and the images which I used that was gray, so I am converting that images in RGB to gray. Then we are resizing that image based on that my model. Here you can see the model size was 48 into 48. So same we are resizing as a 48 into 48. Then we are classifying it. Then the original color image we are displaying this, and the class we are visualizing there. That's all which we are doing. So you see here, instead of IP camera, if I use webcam, let me check if it work. Webcam. Okay, webcam is used to on the inbuilt camera in your MATLAB. Okay. Okay. Let me close this first. So here you can see here it was showing images. So like this, you can predict on live camera also, or if you want, you can deploy this application. Let me clear that first of all, camera which I on it. What is the name of this camera? So like this, you can deploy in FPGA boards, or you can interface with live camera also. This was one example of deep learning, and the previous example which I showed you, that is a machine learning. And in summary, we checked what applications we can use using MATLAB. Apart, this was the session for today. If you have any question, you can ask me. And for and one thing more, if you want to learn machine and deep learning and you want to certificate as well, just search MATLAB or RAMP here on Google and open this matlab.academymathworks.com. Okay. So when you open this, there are some courses, in MATLAB. Like already I completed all courses which are available here free. Like MATLAB on RAM, Simulink on RAM, machine learning, deep learning, state flow. These are free. If you complete this, you will get the certificate as well. If I click on this view certificate, okay, if I go here, you will get a certificate like this. Akhilesh Kumar has completed 100% self-paced training course and signature of a director training service, whatever it is. Okay, if you will complete this, you will get the certificate also. So you have to register on MathWorks to do this training. So if you are really working on machine learning, do this very good way. It is represented here how to extract the features, and all process are given in this machine learning and deep learning as well. Okay, this was my session for today. If you have any questions, please ask.